Good morning, everybody. Welcome to Wednesday morning at Chem 11:05 with your host, me. Have you noticed when I do this, my eyes pop open? Oh, it's Goofy Wednesday. Well, we'll both have to suffer through that. All right, important things. First of all, you should be handing in labs. Don't forget to include a selfie of you with some piece of equipment, whatever, for that lab. Otherwise, for department rules, chemistry department rules, I have to give you zero. That's 0 points. All right, another thing. This morning, I sent out an email that has the link to the test answer coverage I did yesterday that I cut out of the video. But this is a private video, and that's why I sent out the link to you. All right, it's time to get to work. Now, we were talking about moles. Remember, moles is a chemist's counting unit. And if you look at test number 2, important information, one relationship you should know. And in the past, I said you'd have to memorize. I guess I should say you should know how to use is 1 mole of an element equals Avogadro's number. And you should know Avogadro's number, 6.02 times 10 to the 23rd. For an element, 1 mole of an element equals 6.02 times 10 to the 23rd atoms of that element. Also, 1 mole of a compound equals 6.02 times 10 to the 23rd molecules of that compound. And again, in the past, you'd have to memorize this, my class and others too, but mine for sure. But this will be the last page of test number 2. You'll be given that, but you still have to know how to use this. So let's do some more practice. All right, let's take a look at this. Question is, how many moles NaF, sodium fluoride, that's sodium fluoride, I think there's a U in fluoride. I always spell fluoride wrong. How many moles sodium fluoride? By the way, sodium fluoride is a chemical that's put into toothpaste and our drinking water to keep us from getting cavities and have better dental health. Dennis found this out when they found a town, I believe it was in Texas in the 1930s. Almost nobody had cavities or dental problems. And they traced it down to the water they drank had a high level of sodium fluoride. All right, how many moles sodium fluoride are 8.12 times 10 to the 35th molecules of sodium fluoride? Now, what I'd like you to do first is right here or wherever you are, what are you being asked to find? What are you given? We're going to do this stepwise. Right now, all I'm asking you to do is What are you being asked to find? What are you given? All right, everybody's done. So what are we being asked to find? And what I like to do is put a question mark. You can do whatever you want, but that's how I do it. We're trying to find moles of sodium fluoride. What are we given? This number. Molecules of sodium fluoride. Now, the only thing we have to start with, and by the way, once you've done all this, you never have to read, and relax when I use this words, the word problem. Relax. So once we've done this, makes our life easier, which is a good thing. So this is the only number, if I can write it clearly. Let me just readjust my tablet pad. That's better. So this is the only number we have, 8.12 times 10 to the 35th molecules of sodium fluoride. Now, what units do you want your answer to be in? Your turn to try it. I'm going to share the fun today. Now, what I'm doing in teaching is called fading prompts. And after we do this problem, it's also something Winky Dink used to do. Who's Winky Dink? Well, you'll have to wait to find out. So all I'm asking you is, what units do you want your answer in? And everybody's done. Well, you figured that out right here. You're trying to find moles of sodium fluoride. Well, if there is some magic ratio to convert molecules to moles of sodium fluoride, question would be, what goes on top, what goes on bottom, units. And why don't you try that? I'm not asking numbers. And by the way, use your good friend, your good buddy, unit analysis. I'm asking what units go on top of that ratio, what units go underneath. And it looks like everybody's done. So you know what that means? It means it's time to use your good buddy and your good friend, unit analysis. And it's been my good buddy and good friend for many decades. All right, I shouldn't have said that, but it's true. All right, how do you do that? Whatever you're trying to get to, the units go on top of the ratio. What you want to get rid of, unit-wise, goes underneath. So now I'll write moles of sodium fluoride on top. Molecules of sodium fluoride on the bottom. And where do we find a relationship between moles of a compound and molecules of a compound? Well, in case you forgot, you go to important information, test number 2. 1 mole of a compound equals 6.02 times 10 to the 23rd, Avogadro's number, molecules of that compound. 1 mole of a compound equals 6.02 times 10 to the 23rd molecules of that compound. And let me write it here. Just, you don't have to write this when you do the problem, but I just want to remind you and show you. We're in a classroom at COD. This would be on the screen, and I'd be doing the problem on a whiteboard. Well, I haven't found a way to do multiple screenshots in Zoom. And so from test number 2 information, or maybe even memorize this, 1 mole of a compound equals Avogadro's number 6.02 times 10 to the 23rd molecules of that compound. Remember, if you have C equal D, you have two ratios, C over D and D over C. So if we come back here, what number goes on top? 1 mole. Where do we get the relationship of 1 mole to molecules of a compound? Right here. And that would be 6.02 times 10 to the 23rd. Now, before I pick up my calculator, I'm going to check, do my units cancel out? And here we have molecules divided by molecules. Remember, anything divided by itself equals number 1, which means it's canceled out. And all I'm left with is, oh, crooked arrow time. Let's try that again. Better arrow. You're left with moles of sodium chloride. Now, before I calculate, or you can do it afterward, notice this number is 3 significant figures. This 1 is part of the definition, exact number. This is a calculated number, and that's 3 significant figures. And what that means is, I can pick up my calculator now, turn it on, clear it. 8.12, blue double E, 35 divided by 6.02, blue double E, 23. And my calculator gives me this number. Oops. At 1.348837,209 times 10 to the 12. Well, if you put that down, I'm going to take off a point. Why? Because on test number 2, like test number 1, it will say, please use proper significant figures for all calculated answers. And when you multiply and divide in a calculation, you get the same number of significant figures in your answer as the number you're multiplying and dividing that has the lowest significant figures. So this is 3. Exact numbers do not count. This is 3. The lowest number is 3. I'm going to let you round this off to 3 significant figures, and then I will. Your turn. Remember, you're rounding that off to 3 significant figures. This is a skill you need for test 2. All right, let's do it. You keep the 1. That's the first significant figure. After decimal, all numbers are significant. So even though it's, if it was a 0, it'd still be, but it's not. All non-zero numbers are significant. Keep the 3, keep the 4. We use the 8 to round off. Is that 4 or less or 5 or higher? And hopefully I'll pick 5 or higher. So all this I drop, and this I increase by 1. And I'm going to move this down here so we have more room. And that's equal to 1.35 times 10 to the 12. Oops, forgot the 1 there. Moles of sodium fluoride. And that's how you do this. All right, a couple things I should mention. One important one, a Dr. White story. Test number 2 historically has the lowest average, but not always. I've had classes where it's been very high, but sometimes it's been very low. You have to start, well, you don't have to, but I highly recommend you practice. Look at chapter 5.1 to 5.4 practice problems. There are more problems like this. Students who don't practice have problems on test 2. Now, what I've been doing is called fading prompts, but it reminds me when I was a kid, like about 6 years old, 7, there was a great program called Winky Dink and You. You can see this. And what you did was, it was a cartoon program, and every once in a while, Winky Dink had these adventures, and he'd get stuck in something. And you'd send in, your parents would send in, I think it was a phenomenal amount of money, like 25 cents, and they'd send you a piece of plastic and a grease marking pencil. And what you did, because of static electricity, as you see here, well, they said 50 cents. I don't remember it was that expensive, but it could have been. You put it on the screen, and at certain times it would say, kids, Winky Dink is stuck in this hole of a ship. Draw him a ladder so he can get out. And they'd have dotted lines so you could draw the ladder. And then after an amount of time, he'd go up your ladder. It was cool. I mean, it was really cool. And if you go to YouTube and you see this picture where the girl's drawing on the screen, it's not on the picture tube of the TV. We had a better one than that one when I was a kid. But you'd have that plastic on there, so you weren't. Well, and here they have a Winky Dink opening, nothing much more, I'm surprised. But anyways, whenever I do fading prompts, I think, oh, I'm doing a Winky Dink thing for my students. Oh, by the way, true story, I don't tell false stories, but my best friend, Dickie Gale, forgot to put the plastic on the screen. So he's writing on his parents' TV. Oh, did he catch it? Ooh, he did a couple things he caught it for. You never wanted to get Dickie Gale's mother mad at you. Ooh, she could be really really mad, and it wasn't fun. I was around a couple times when she let loose on him verbally. All right. One other thing I want to point out, and I've said this a couple of times about checking your units. This is the correct way. What if you did it backwards? And I'm not going to put the numbers in. We look at this, which is wrong. How do we know it's wrong? Well, what units do you want to get? Moles of sodium fluoride. If you did this right here, what units would your answer be? Well, it's molecules of sodium fluoride times molecules. Divided by moles, NaF. And notice nothing cancels out, and this is not what you want. And that's how you should always check your units. Because in the right answer up here, we have molecules of sodium fluoride times moles of sodium fluoride divided by molecules of sodium fluoride. So on the correct way, you would see molecules of sodium fluoride divided by molecules of sodium fluoride. Anything divided by itself is the number one, and that's why you end up with the right units, moles of sodium fluoride. All right, it's time to move on, but really do the practice problems. Do them now. You're not going to learn chemistry, this chapter's the day before a test. All right, we did our mole practice time, number one, with unit analysis. Your good buddy, your good friend, unit analysis. Let's move on. There's a new concept I'd like to talk about, and I think I better be subtle. Subtle, huh? Know this. That's called molar mass. Now, for a compound, this is important. The sum of the atomic masses of all the atoms in its, this is the sum of all atomic atoms in its molar mass. Now, the molar mass, I'm going to call, meaning me, your instructor, will call molecular weight. And it's abbreviated, I use MW. So what's the molecular weight? It's the sum of all atomic weights of all the atoms in a molecule. So the molecular weight, MW, is the sum of all atomic weights of the atoms, all atoms in a molecule. Where do we get atomic weights? Well, if you look at your friendly neighborhood periodic table, underneath the chemical symbol is the atomic weight. And if we look at hydrogen, you see under there 1.008. That's the atomic weight for this periodic table of hydrogen. If we look at oxygen, oh, it's 15.999. Carbon, 12.011. And those are the atomic weights. Now it's time for a little gift from Dr. White. It's just a little gift, but it'll make your life easier, which is a good thing. At least I think so. And that is on test 2, 3, 4, and the final. Why do I do it? On the final, it will say underneath your name, 1, you're already used to. Please use proper significant figures for all calculated answers. And now for my gift from me to you, a little gift, but it makes your life easier. It will also say, please use all atomic weights to 3 significant figures. Again, it will say, please use all atomic weights to 3 significant figures. So let's do some practice time. Now I have here calculated the formula mass. I probably would say on a test, calculate the molecular weight of the following. Well, let's do it. I probably would do what is, let me rewrite this. And the first one, 3 points each. What is the molecular weight of water, H2O? Well, how do you do that? Well, the molecular weight is the sum of all atomic weights. Well, we have 2 hydrogen atoms and 1 oxygen atom. So that would be 2 times the molecular weight of hydrogen. Well, what is that? Well, you got to look at your periodic table unless you use it as much as I do. And you see 1.001. But on test 2, it will say, please use all atomic weights to 3 significant figures. So how do you do that for hydrogen? Round it off to 3 significant figures. Keep the 1, keep the 0. There's decimal points, so that's 0 significant. Keep the second 0. Use the 8 to round off. Is that 4 or less or 5 or higher? And hopefully you pick 5 or higher. You drop that and the number in front is increased by 1. So the 3 significant figures, hydrogen atomic weight is 1.01. And there it is. And I'm multiplying it by 2 because you have the sum of all atomic weights. Now for oxygen, there's only 1. And the question is, what's the atomic weight of oxygen? If we look here, it's 15.999. Remember, the number underneath the chemical symbol is the atomic weight. So how do we round 15.999 to 3 significant figures? I'm going to do that on the whiteboard because this might be a little tricky. How do you round this number off to 3 significant figures? Keep the 1, keep the 5, keep the 9. Next number I use to round off, and that's this 9. Is that 4 or less or 5 or higher? It's 5 or higher. So I'm going to drop that and increase that by 1. Well, that becomes 1.0. And 1.0 added to 15, the correct to 3 significant figures is 16.0. And let me do that again. You want to round this off to 3 significant figures. Why? Because on test 2, I will have under your name, please use all atomic weights to 3 significant figures. And if you don't, I'll take off a point. You lose a few points, that's going to hurt. You don't want that. So how do you round off 15.999? Keep the 1, keep the 5, keep the 9. That's our 3 significant figures. Use the next number 9 to round off. That's 5 or higher. I'll drop that. And this other 9, the last, this 9 after the 5, I'll keep, but I'll increase by 1. I get 1.0 added to 15, and the correct number is 16.0. Do the math. These are, and here, this is 16.0. Now, the molecular weight is the sum of all atomic weights. So now I'm going to add 2.02 plus 16.0. And this is the number you get. Now, I skipped it earlier, but I'm going to have to talk about it now. When you add, you get the same number of significant figures to the right of the decimal point as the number that has the fewest significant figures to the right of the decimal point. Now, it took me when I first learned this a while to wrap my head around it. Anything to the left of the decimal, you just add up and you don't change. Anything to the left of the decimal, when it adds up like 18, you don't touch it. Now, to the right of the decimal, you get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures to the right of the decimal. How do we do that? Here's my decimal point. All numbers to the right are going to be significant. This number has 2 to the right of, not the whole number, just to the right of the decimal point. Next, 16.0, the 0 is significant. So these are the numbers, significant figures to the right of the decimal. So which one of these is the lowest? Hopefully you pick this one, 1. You know 1 is less than 2. And for addition, you get the same number of significant figures to the right of the decimal as the number that has the fewest. So now we have to round this off, not the whole number, just to the right of the decimal. All numbers are significant. Keep that. That's my one significant figure. Use this to round off. Is that 4 or less? Yes, I drop it. And the correct answer is 18.0. All right, let's do another one. What I have, oh, ammonia. All right, so the question is, what is the molecular weight of ammonia? And remember, the molecular weight is the sum of all atomic weights of the atoms in that molecule. Ammonia has 1 nitrogen and 3 hydrogens, which means 1 times the atomic weight of nitrogen, 3 times hydrogen. Well, we've already done that up there. We rounded 1.008 to 1.01. Well, what about nitrogen? What's the atomic weight of nitrogen? Well, you go to your friendly neighborhood periodic table and you find nitrogen. Now, nitrogen has an atomic weight of 14.007. But on test 2, 3, 4, 5, no, there's no 5 in the final, but test 2 for coming up after spring break, a couple weeks from now, you have to round that off to 3 significant figures, because it will say underneath your name, please use 3 significant figures for all calculated answers. So how do you round 14.007 off to 3 significant figures? That's your turn. I'm going to let you have some fun. I don't want to hog all the fun. So round 14.007 to 3 significant figures. Your turn. All right, looks like everybody's done that. Wow, that was quick. So how do you do that? Keep the 1, keep the 4, keep the 0. Remember, any number, any 0 after the decimal point will always be significant. Use the number after this 0 to round off, which is a 0. Is that 4 or less? Yes. So I drop that and that, and the correct atomic weight for nitrogen is 14.0, which is why I put it in there. 1 times 14.0, 14.0, 3 times 1.01 is this. And the molecular weight is the sum of all atomic weights, which is what I'm doing, and you get 17.03. Now, is that the correct answer? No. And the reason is, as it will say under test your name, test number 2, and the other test and final also, please use proper significant figures for all calculated answers. And for addition, you get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures to the right of the decimal. Well, here's my decimal. This has 1 significant figure to the right of the decimal. This has 2. And when you add and subtract 2, but I don't think we do any subtraction, you get the same number of significant figures to the right of the decimal. I like my special effects. Not. But anyways, so you have to round this off to 1 significant figure to the right of the decimal. Guess what? Your turn. Try it. Round 17.03 off to the correct number for that addition. All right, my turn. The lowest number of significant figures to the right of the decimal is 1. It's not always that, but for this, and I keep the 0, use the 3 to round off. 4 or less, yes. So I'm going to drop that. And the correct answer for the 3 significant figures is 17.0. Now, one interesting side note, I'll be teaching you later this semester, probably tomorrow even, I think. Not tomorrow, it's Wednesday. Next Monday, about a way of calculating certain things for how much of a chemical for a chemical reaction. Now, in a chemical plant, you use large amounts of chemicals. We're talking a couple 100,000 pounds for one reaction. And I've worked at companies where part of my job was to write up the procedure. Some companies call them recipe, like when you're in your kitchen cooking, how much of each chemical to mix together to make a product. And you're talking a couple 100,000 pounds of chemicals and a couple $100,000 of money. And you don't want to mess up because you get fired. Never happened to me. But you don't want to blow a couple $100,000 of money because you made a mistake. When I have to use atomic weights to get molecular weights, I always use 3 significant figures. I never had a problem. So that's real life. Oh, let's do another one. Three points. What's the molecular weight of sodium hydroxide? I can spell it. And how do you do that? Well, the molecular weight, remember, I'm asking you, what is the molecular weight of 3 points each, excuse me, sodium hydroxide? And the molecular weight is the sum of all atomic weights. Well, you got 1 oxygen. We've already figured that's 16.0, the 3 significant figures. 1 hydrogen is 1.01. Now, what about 1 sodium? Well, let's go, excuse me, getting all choked up over this. Let's go to our friendly neighborhood periodic table. And sodium, you see 22.989. Well, how do we do that to 3 significant figures? And why don't you round this off to 3 significant figures? Your turn. Because on test 2, we'll say, please use all atomic weights, the 3 significant figures. All right, how do you round this off? Keep the 2, keep the 2, keep the 9. Those are 3 significant figures. Use the 8 to round off. Is that 5 or higher? Yes. So I'm going to drop that, increase that 9.9 to 1.0 by increasing it by 1. So how do you do that? You add 1.0 to 22, and the correct atomic weight for sodium is 23.0. Well, since they're one of each, I'll do the math. If you add all these up, this is what you get. But don't forget, you get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures to the right of the decimal. So what would you round 40.01 off to get the corrected number for this addition? Your turn. Why don't you try it, and then I'll do it. All right, looks like everybody's done. How do you do that? You have to look how many significant figures to the right of decimal. And all numbers and zeros are significant to the right of decimal. This is 1. This is 1. This is 2. Which is the lowest number? And hopefully you pick 1. So how do you round this number off to one significant figure to the right of decimal? Keep the 0, use the 1 to round off. Is 4 or less. So the correct answer on my test would be 40.0. And that's how you do atomic weights. And you'll see it's an important skill to know how to do. And if I look at the clock, it's time for a break. I'm going to get up and stretch. Let's take a 5-minute break and continue on after the break. me do that again. That was better. I'm back, if you haven't figured that out. All right, let's continue where we left off. Now, we were talking about molecular weight, which is the molecular weight is the sum of all atomic weights of the atoms in a molecule. And the atomic weight you get from the periodic table. And we did our practice time. Now, one of the most important concepts in all of chemistry, for me, Dr. White, is the relationship called the molar mass. And I'll never ask you what it is, but, and this, let's go through this slide, and I'll show you a better way of understanding it. Element molar mass, or the molar mass of an element, that's the quantity in grams of an element that equals the atomic mass of an element. The molecular molar mass is the quantity in grams of a formula mass, otherwise known as molecular weight. Of a molecule equals the formula mass of the molecule. Now, what does that really mean? What it really means is for elements, and this is one of the most important things I know in chemistry, 1 mole of an element equals the atomic mass in grams of that element. 1 mole of an element equals the atomic mass in grams of that element. And this is important, if not more, for compounds. 1 mole of a compound equals the formula mass, otherwise known as the molecular weight in grams of that compound, which is why I just spent the last, before the break time, teaching you how to calculate the molecular weight. Now, let's go to important information, test number 2. And you'll see here something in the past you'd have to memorize, I will give to you. 1 mole of an element equals the atomic weight of that element in grams. 1 mole of an element equals the atomic weight of that element in grams. 1 mole of a compound equals the molecular weight of that compound in grams. 1 mole of a compound equals the molecular weight of that compound in grams. And what we just went over, I also give you the molecular weight of a compound is the sum of all atomic weights in that compound. Am I nice or what? Don't answer that. And like I said, these, for me, are probably some of the most important concepts in all of chemistry, period. So what does that mean? Determine the mass or the molecular weight in grams of 1 mole of the following. And mass means grams. I do have it there, mass in grams, or the weight. So what's 1 mole of silver weigh? Good question. Well, 1 mole of silver equals atomic weight in grams of silver. So we now have to go to our periodic table, and where's silver in the high rent district? It's 107.868. Now, if you round that off to 3 significant figures, it's 108. So 1 mole of silver, Ag, is 108 grams. Now, if you really write nice to Dr. White, you could send me a mole of gold, What's gold? Chemical symbol AU, rounded off, 196.967 to 3 significant figures. Well, if you want to send me a mole of gold, that's only 197 grams. Remember, 1 mole of an element equals the atomic weight of that element in grams. If I wanted a mole of sodium, well, that's the atomic weight is equal to 1 mole of sodium in grams. And that's 22.989. The 3 significant figures is 23.0 grams. So if I needed a mole of sodium, I'm not going to count out 6.02 times 10 to the 32, 23rd atoms of sodium. One, I can't see an atom. I'm not Superman. I don't have X-ray vision. But even if I did, I'm not going to count those out. All you have to do is weigh it out on a scale, a balance. And that's the beauty of this concept. Now, let's look at what's the mass, how many grams are 1 mole of water? Well, water has this formula. And what do we need? Well, you need to remember 1 mole of a compound equals the molecular weight of that compound. Oh, in grams, and we've got to find out what's the molecular weight of water. Well, we already did that. The molecular weight of water we calculated earlier is 18.0. That means 1 mole of water is 18.0 grams. Remember, the molecular weight of a compound equals the mass in grams of 1 mole of that compound. So 1 mole of water equals the molecular weight, 18.0, and that's in grams. Now, on that sheet, it also asks, what's the molecular weight of ammonia, NH3? Well, how do you do that? In case you forgot, the 1 mole of a compound equals the molecular weight of that compound in grams. So if I need to find 1 mole of ammonia, what do I have to do? Excuse me. You have to find the molecular weight of ammonia. And we did that. NH3 ammonia, the molecular weight is the sum of all atomic weights, and that's 17.0. Therefore, 1 mole of ammonia is 17.0 grams. By the way, Dr. White's worked a lot with ammonia, including large amounts. One of my less favorable memories was because I was at a plant and they needed some extra help, which I would do. The foreman asked, could you supervise unloading a railroad car of a couple 100,000 pounds of liquid ammonia? That was more than 1 mole. And what was how should I say, something I like to forget was it was the middle of summer. It was like 90 out and high humidity. And you had to get up in a full hazmat with a full face gas mask, air tank on your back. And if you were sweating, which I was, and started going into your eye, you took the mask off, you'd be dead. No, I didn't take it off. I'm still alive. Good thing, too. I think so. But anyways, what's the molecular weight of ammonia? We calculated it. And that would be equal in grams, 17.0. Grams is 1 mole of ammonia. If I needed in a lab to use 1 mole of ammonia, I would weigh out 1 mole of ammonia. And I've done that. I've also supervised in the lab doing about 5,000 pounds of ammonia. That's a lot. So, and sodium hydroxide, we calculated earlier, the molecular weight of sodium hydroxide is 40.0. And what would 1 mole of sodium hydroxide weigh? 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight is the sum of all atomic weights in grams. And as we calculated earlier, the atomic weight of sodium, molecular weight of sodium hydroxide is 40.0. So to get 1 mole of sodium hydroxide, you would weigh out 40.0 grams. That's not hard. But now let's have some real fun with this. Now, you know my chemist. Yep, 10 points. I used that number before. Oops. All right, let's look at the following. The question is, how many grams, that's what G is, water, are 3.671 moles of water? And remember, 10 points. So how do we do this? Well, you know the routine. What are we being asked to find? Grams of water. What are we given? 3.671 moles of water. So what do we do? Well, this is the only number we have to work with. And if I had a ratio, one number over another, to convert it, what answer do I want what units do I want my answer to be in? And we figured that out. Grams of water. So how do we proceed? Well, it's time to use your good buddy, your good friend, unit analysis. And how do you do that? Whatever you're trying to get to, the units go on top, and whatever you're trying to get rid of, the units go underneath that ratio. Oops, wrong color. So I have a ratio of grams of water to moles of water. And where do I find that relationship? And I'll write it here so we don't have to. 1 mole of a compound equals the molecular weight in grams. Remember, MW is molecular weight in grams of the compound. Uh-oh, we don't have the molecular weight of water. Well, also remember the molecular weight in grams of a compound equals the sum of all atomic weights of the compound. And in the past, you'd have to memorize that for my class. But just to remind you, if you look at important information, I have 1 mole of a compound equal the molecular weight of that compound in grams. And I also have for you, in case you forgot while you're taking the test, the molecular weight of a compound equals the sum of all atomic weights in that compound, and that's in grams. So we've already done this, but let's do it again. We need to find out for every 1 mole of water from here, that's equal to the molecular weight of water. So we have to calculate the molecular weight. And the molecular weight of water, as we did before, 2 hydrogen, 1 oxygen, and that would be the sum of all atomic weights. Do the math. Round it off, and the molecular weight of water to the correct significant figures. Remember, when you're doing molecular weights, use all atomic masses or numbers, atomic masses. The 3 significant figures is 18.0. That's the molecular weight of water. And therefore, we can put it in here because 1 mole of a compound water equals the molecular weight of water. And don't forget, when I have 1 mole, C, equal the molecular weight, D, you can have 2 ratios, C over D, and a second ratio, they're not equal, D over C, which is how I got this. 1 mole of a compound or 18 point molecular weight of the compound per 1 mole. And now, before I pick up my calculator, I'm going to check my units. Notice moles divided by moles, and anything divided by itself equals the number 1. Cancels out. So this cancels out. I'm left with grams of water. That's what I want. So I can pick up my calculator with a big smile because I'm on the right track. Clear it. 3.671 times 18.0. And my calculator gives me the number 1. And you have to round this off. Notice this is 4 significant figures. This is 3 significant figures. The 1 is an exact number. It's not used in your calculation. And now, when you multiply and divide, you get the same number of significant figures in your answer as the number that has the fewest significant figures in your answer. And which is lower, 4 or 3? exact numbers you don't use. And the answer is 3. So I round this off to 3, keep the 6, keep the 6, keep the 0, use the 7 to round off. That's 5 or higher, drop that, increase this by 1. And that's my answer right here. So if I need 3.671 moles of water, I go to the lab and weigh out 6.61 times 10 to the first grams of water, which if you convert it to decimal, which you don't have to do in my class, but I do, would be 66.1 grams of water. And remember, 10 points. Whoa. Let's do another one. All right. Question is, how many moles HCl? HCl, we'll talk about later in the semester, is hydrochloric acid. And hydrochloric acid, this is one of the miracles of life in my mind, is the acid your stomach makes to break down food, digest it. In your stomach, you have cells that make HCl, and that's used to break down your food when you consume it. And when I was little, about 2 or 3, my mother said, chew your food before you swallow it or you'll choke. And guess what? I found out she wasn't lying to me. I did choke. By the way, in case you're wondering, I lived, but I learned my lesson the hard way. Sometimes through life, I've done that, learned lessons the hard way. I guess all people do. So let's do a partial winky dink on this. First question you should do is, or think to do is, what are we trying to find out? What are we given? Your turn. Again, all I'm asking you to find out is, what are you being asked to find? What are you given? All right, looks like everybody's figured it out. My turn. So what are you being asked to find? How many moles of HCl? HCl, hydrochloric acid. What are you given? 4.371 times 10 to the third grams of HCl. Now, this is the only number we have to work with, so I will. Now, if I had a magic ratio, it's not magic, it's chemistry. Your turn. What units do I want my answer to be? And all I'm asking is what units, and put it if you were setting it up. And I see you're done. And we figured that out right here. That's why we took. So we want to get to moles of HCl. Now, I'm going to let you use your good buddy, your good friend, unit analysis. What units go on top and bottom of that? Not numbers, just the units. All right, my turn. And it's time to use your good buddy, your good friend, unit analysis. If you notice, I love that. If you guess, whoops, hold on, I just dropped my pen. I'll be right back. Hang in there. Sorry about this. This is my stylus I use on my whiteboard, and it fell on this first time ever happened. Fell and rolled all the way under my desk. I had to climb under there and get it. All right, let's get back to our problem. Question is, what units do we go on top and bottom of this ratio? And you use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of that ratio. Whatever you're trying to get rid of goes underneath. So I have moles of HCl on top, grams of HCl, hydrochloric acid, on the bottom. Where do I get these numbers that I put in that ratio? 1 mole of a compound equals the molecular weight of that compound in grams. The molecular weight, MW, in grams of a compound is the sum of all atomic weights of that compound. So I have to figure out, this is why it's 10 points, because it's a lot of work, what's the molecular weight of hydrochloric acid? Well, hydrochloric acid has 1 hydrogen, 1 chlorine. Well, where do we get those? Well, hydrogen, we already figured out, is 1.01. What about chlorine? Well, you go to your friendly neighborhood periodic table and you see it's 35.453. Remember, on test number 2, it will say underneath your name, please use 3 significant figures for all atomic weights. So now we have to round off 35.453 to 3 significant figures. Guess what? I'm going to be nice and let you do it first, then I'll do it. So round off 35.453 to 3 significant figures. And seems like everybody's done. That answer would be 35.5. So the atomic weight of chlorine, the three significant figures, 35.5. If I do the math, 1.01, 1 times that, and this would be 35.5. Add it up. This is the number I get. Now, remember, when you're doing addition, you get the same number of significant figures to the right of the decimal as the number with the fewest significant figures. So for this one, it would be 2 significant figures, 1. Therefore, this should be rounded off to 1 significant figure to the right of the decimal. Guess what? I'm going to let you do it first, and then I'll do it. Round 36.51 to the correct number when you do that addition. And it looks like everybody's done, so it's my turn. And you get the same number of significant figures to the right of the decimal as the number with the fewest significant figures to the right, which is 1. So I keep the 5 and use the 1 to round off. That's 4 or less. So the molecular weight of hydrochloric acid is 36.5 grams equal 1 mole. And let's remember, 1 mole of a compound equals the molecular weight of that compound. So 1 mole of hydrochloric acid, HCl, equals the molecular weight of hydrochloric acid. Now, before I pick up my calculator, I was about to, no, check your units. Notice we have grams of HCl divided by grams of HCl. Anything divided by itself becomes the number 1, cancels out. This cancels out. What am I left with? Moles of HCl. That's what we want. We're on the right track. So I will take 4.371 blue double E times 10 to the third divided by 36.5. Ha! And my calculator gives me this number. And remember, you get the same number of significant figures in your answer when you multiply and divide as the number that has the fewest significant figures. And if we look at what we just did, this has 4 significant figures. 1 is an exact number, doesn't play a role. And this has 3 significant figures. What's the lowest number? This. So now you have to round off to 3 significant figures. Because on test number 2, I'll say, please use proper significant figures for all calculated answers. If you don't, I take off a point. Your turn. Round that off to 3 significant figures. Well, this is a little challenging. Let's see if you're up to it. Again, you're rounding that off to 3 significant figures. And when you're done, don't forget to vote. All right, my turn. Three significant figures, keep the 1, keep the 1, keep the 9. Use the 7 to round off. Is that 4 or less or 5 or higher? It's 5 or higher, so I drop this, everything afterward, increase that by 1. Increasing that by 1, increase it 1.10, which you add to this, and that would be the number. This rounded off to three significant figures is that number, 1.20, 10 squared moles of HCl. Important public service announcement from me, Dr. White, the management, and that is on a test, show your work. If you write down a number and it's wrong, like even if you round it off wrong, and you showed no work, I give you 0 points. Out of 10 points, if you make a math error, round off, or push the number, one of the wrong buttons on your calculator, and it gave you the wrong number, but you show your work, out of 10 points, I would give you 9 points. Or if you make another mistake, but it's minor, you'll get most of the points. So it pays point-wise, which means your grade, to show your work on my test. End of the public service announcement. Oh, these are fun. Let's do one more. I'm hung up on the number 8 today. And the question is, how many grams KOH? KOH is potassium hydroxide. It was originally found in the ashes underneath in wood, and our forefathers and mothers would do that under the pot they would be cooking in. That's where they found potassium hydroxide, and it has the old name potash, because that's where they found it, in the ashes underneath the cooking pot. Well, anyways, first thing I'm going to have you do is 1. What are you being asked to find? What are you given? Your turn. Oops, wrong place. All right. What are you being asked to find? How many grams of KOH? So we're trying to find grams of potassium hydroxide, KOH. What are we given? 7.5 times 10 squared moles of KOH. Well, we only have one number to start with, so I'm going to start with that. And we had some ratio, something over something else. What units do I want my answer to be in? Your turn. All right. The answer is, well, we figured that out. That's why we take this time to put the question mark, and we want grams of KOH. Now, what units do you want on top and bottom of that ratio? Use your good buddy, your good friend, your analysis. Your turn. All right, my turn. It's time to use your good buddy, your good friend, unit analysis. How do you use your good buddy or good friend? Whatever unit you're trying to get to, go on top of that ratio. Whatever units you're trying to get rid of, go underneath. And so I'm going to write them in. And where do I find a relationship between moles of KOH and grams of KOH? Moles of a compound and grams of a compound? In case you forgot, important information, test number 2, 1 mole of a compound equals the molecular weight of that compound in grams. 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights. So I know 1 mole of a compound equals the molecular weight in grams. Oh no, they didn't give it to us. We've got to calculate it. So we now have to calculate the molecular weight of KOH. The molecular weight is the sum of all atomic weights, 1 potassium, 1 oxygen, 1 hydrogen. This we already know is 16.0. This is 1.1. We've done it before. Now, what's the atomic weight of potassium? The 3 significant figures. Well, you have to go to your friendly neighborhood periodic table and notice it's 39.098. You round that off to 3 significant figures. Keep the 3, keep the 9, keep the 0. Use that second 9 to round off. Is that 4 or less or 5 or higher? Hopefully I'll pick, I like my buzzer. But anyways, round that off. That's 5 or higher. Drop the 9, drop the 8, increase the 0 in front of the 9 by 1, and that's 39.1. Add these up. Hopefully I added it up right. Yes, I know this one by heart because I use it a lot. And this has 1 significant figure, 1 significant figure, 2 significant figures to the right of the decimal. And when you're adding things up, which we're doing here, you get the same number of significant figures to the right of the decimal as the number that has the fewest. Hopefully you pick 1. And if we round this off, keep the 1, use this one to round off, and the correct answer is 56.1. And that equals how many grams? 1 mole of KOH equals that. So I can now put this in here. Before I pick up my calculator, I was about to, bad, Dr. White. Moles of KOH divided by moles of KOH. Anything divided by, hold on, I don't want to write there. Anything divided by itself equals number 1, meaning it cancels out. This cancels out. I'm left with grams KOH. That's what I want. So I can pick up my calculator. 7.5 blue double E times 10 squared times 56.1. Oops, I made a mistake. Let me clear it again. Hold on. And my calculator gives me this number. And this has two significant figures. This has three significant figures. This is an exact number, doesn't play a role. And the number of significant figures in your answer is the same number of significant figures in your, let me say that again, I got confused. I do that once in a while. The number of significant figures in your answer is the same number of significant figures as the number you're multiplying and dividing that has the lowest significant figures. In this case, it's 2. Round this off to 2 significant figures. Keep the 4, keep the 2. If you want to do this on your own, press pause on the video and then do it and turn it on again. If you're not, keep the 4, keep the 2. Use the 0 to round off, that's 4 or less. Drop that, and the correct answer is so if I need 7.2 times 10 squared moles of KOH, I'd weigh out 4.2 times 10 to the 4th grams of KOH. And that's how you do it. I would highly recommend, A, you go back and review these 3 problems I did. They're in the video. 2, I'd highly recommend that you try these in the practice problem. These are not simple problems if you haven't practiced them. If you have practiced them, they're simple. And with that, I'm done for today. I'm done for the week. Don't forget, if you have any questions, I have tonight, Wednesday, my office hour from 6:15 or 6 to 7:15 on Zoom tonight. And have a nice rest of the week. If I don't see you tonight, gehen gesund means go in health in Yiddish, and goodbye. I stole that from Granny and the Beverly Hillbillies. Bye now.